Hello learners, this is the third lecture on lasers. In the first one we have learned about the characteristics. In the second session we have learned about the absorption and emission phenomena. Now we are going to learn metastable state, population inversion and pumping mechanism. Metastable state. So to have a clear understanding of it, let's say that we are having three energy levels. E1 is indicating the ground state, E2 is the first excited state, E3 is the second excited state. The atom resides in the ground state for longer time, that is infinite amount of time, until and unless we give some energy, the atom remains here only. For metastable state, we are not worried about the ground state. We are only looking for the excited state. In the E2 state, suppose we are having the atom to be residing for 10 power minus 3 seconds. Suppose that in E3 state it is residing for 10 power minus 9 seconds. I am saying suppose that in E2 state atom is residing for 10 power minus 3 and in E3 state it is residing for 10 power minus 9 seconds. Now, if we compare these two excited states, atom is staying longer time in E2 state compared with E3 state. So, E2 is called as metastable state. We can define it as the excited energy state of an atom that has a longer lifetime. That means if atom has longer lifetime in a particular energy state, that energy state is called as metastable state. Population indicates the atoms present in a unit volume. E1 is a ground state consisting of n1 number of atoms in a unit volume. Then we say n1 is its population. E2 is the first excited state consisting of n2 atoms in a unit volume. Then we call n2 is its population. E3 is consisting of n3 atoms in a unit volume. Then we call n3 as its population. So population is defined as the number of atoms per unit volume in an energy state. Population inversion. In general, atoms reside more time in E1 state compared with the excited state. Unless until energy is given, the atoms reside here. But when energy is given, they move for higher states. So in this continuous supply of energy, there is a continuous transition of atoms from one state to another, excitation and de-excitation. During this process, if an excited state has more number of atoms compared with the other energy states, then we say that population inversion is achieved. So for this, you are having E1 state consisting of N1 atoms when energy is supplied and energy which is equal to E3 minus E1 H mu is given, they rise to E3 state. There they do not remain for longer time. There will be a random spontaneous emission from E3 to E2 state. A rapid decay is observed. In this E2 state, the atoms reside for longer time, and because of this metastable state, we have population inversion to be achieved. That means atoms are more in number in this excited state compared with the higher excited states or the ground state. Then we say that population inversion is achieved between E2 and E1. That is, if you are having a particular energy state, more number of atoms compared with the other two energy states, then we say that population inversion is achieved. The last one we are having for today's class is pumping. To excite the atoms or de-excite, we can have amount of energy to be supplied. This process of supplying the energy for the laser medium to achieve population inversion is called as pumping. So you are applying some sort of energy. That energy could be optical energy, electric discharge, direct conversion, chemical reaction, collisions, etc. So what is the type of energy that you have supplied for the laser medium to achieve population inversion? That gives you the pumping. For solid state lasers, we have optical pumping. For gaseous lasers, we have electric discharge. For semiconducting materials, generally we go for direct conversion. So the process of supplying the energy for the laser medium to achieve population inversion is called as pumping. This is for today's session. Thank you.